Welcome everyone to this latest webinar. Today we're basically looking at the carbonising energy through efficiency in the boiler housing and webinar from Endress+Hauser. It's also hosted by Process Industry Informed magazine, which is the leading process industry resource. Endress+Hauser is a global leader in measurement instrumentation services and solutions for industrial process engineering. This webinar takes a detailed look at the benefits of energy management and monitoring on steam boiler plants. I'm your host, Dave Howell, and I'm really glad to be joined by Wes Allen today, the Power and Energy Industry Manager at Endress+Hauser, who has 30 years of experience in the field of process instrumentation. Welcome, Wes.
Thank you.
Well, it's great to have you on today. I think the presentation which you're going to give is. I think it's a fascinating insight, and I think everyone that's joined us today for this webinar is going to learn a great deal. I think by the end. But before we sort of kick off, I would like to say to everyone that has joined. Do send any questions in that you really want to put to Wes. You'll see how to do that on the bottom of your screen. Please do send any questions over. I'll be monitoring that while Wes is actually speaking. And I will interrupt Wes if there's a question that does come in a particular slide, or if any of you want some more information about something that maybe Wes has mentioned. So don't hesitate to make to send a question in. So I'll be tracking all of that while Wes is speaking. And if you do need any more information, then do send your questions across. So Wes, what I'm going to do is I'd like to pass this over to yourself. If you could obviously share your screen for the presentation. What I will do is I'll stay live as well. And what I'd like to do is if anything occurs to me that I think I'd like some more information on, I will come back to you with my own questions if that's okay. So it's really down to you, Wes. What I'd like to do is hand over to yourself to kick off your presentation. And again, everyone that's joining us today, if you do want to send a question in, then please do. So Wes, while you get your screen sorted, I'll give you.
Can you see that?
So, I can indeed, and I think everyone else who's joined us today can as well. So over to you, Wes.
Thanks very much, Dave. I guess the backdrop to this presentation was the launch of the government's net zero strategy, which coincided with COP26 in October last year, and it's obviously all about decarbonisation, but we're in transition, and decarbonisation is very complex, and it's complex for two main reasons. One is the uncertainty in the fuel prices and energy prices and carbon prices, and the other thing is that the technologies are developing, they're unproven and they're expensive. So we are in transition, and one of the key requirements from the government strategy is that we're more aggressive with energy efficiency and heat recovery and energy management, because this is all we'll have in the first few years, along with some of the more proven technologies like heat pumps.
Do you find that when you actually speak to your client base, when you're sort of called, when Endress+Hauser is asked to I guess provide some solutions to those questions, do you find that in the industry that, as you say, there's a lot going on, there's a lot that these businesses have to look at? Is there a level of, I won't say confusion, but is there a level of anxiety about what they have to do, I guess, on a practical level? And that's really what they come to you guys to provide that sort of clarity.
Absolutely. I think, especially with wholesale gas prices, the spikes in the last year of they're over 400 pence a therm at the minute. So people at the start of last year might have been paying less than a couple of p for kilowatt hour of gas, are now paying close to 8p and more in many cases. So some of these customers have major choices in reducing production, maybe just stalling production for a few months, or as some of our customers are doing now, they're looking into more polluting fuels. So this goes against climate change, but it's just it's a basic survival.
It's an economic
tactic.
thing,
It is absolutely just to survive and keep going. And so this presentation starts, and it's a look really at most of the fossil fuels used in industry are for heat. A lot of that heating is through steam, and I see a lot of boiler houses, steam boilers, and they're not always well instrumented to get a lot of the KPIs that we can get to understand the performance. So there's a lot more we could do. Most of the fuel that's used in industry goes through that boiler house. So I broke the presentation down into just a few sections, really, just to have a look at what I think are the key instruments around the boiler. This is not about instrumenting a boiler house as such. We're not talking about water or steam quality instrumentation. We're not talking about boiler level controls. It's purely about the energy in and out of that boiler. We'll look at the different types of KPIs available, the efficiencies that we can determine and how we can get those. And we'll have a look at how we could automate these and set meaningful targets against the fuel for steam demand. And I'll just touch on compliance, because heat now is the fourth utility. We're going to see probably a doubling in the amount of heat networks over this decade, and there'll be a lot more schemes introduced by the government over the next years. So for the instrumentation, as I said, we're only looking at the boilers themselves. And can you see my cursor here?
I can indeed.
Okay, yeah. So I've just done an example here, just a couple of boilers. We've got feed water meters, we've got temperature, there's an economiser, so we've got temperature sensors before and after the economiser. We've got a fuel meter, we've got steam meter pressure. And what we're going to look at is what we can do with the information from those instruments. Looking at maybe the economiser heat recovery, being able to compare that for more than one boiler, can be a condition monitor, can give us information on how that boiler's performing. We need to obtain mass before we can get to energy. So again, you see lots of volumetric meters on boilers, but without getting to mass first, we can't get to energy. And so we're going to look at what we need to do there for mass. We're going to look at the fuel energy, fuel to steam efficiency, maybe blow down losses and condensate return. So these are all of the easy to obtain KPIs or metrics for that boiler performance that give us a good picture of how efficient it's operating.
Yes, it seems to me, I mean, in this specific example, of course, it's we're talking about boiler efficiency. But I think a lot of people listening to this webinar, of course, they're in industries and the process issues where they're using. It kind of is about data, isn't it? It is about, if you can't see it, you can't optimize it. As we said at the beginning, the price is the price, and there's little you can do about that. But what you can do is make sure the energy and the inputs that you are using those as efficiently as you can. And the only way to do that is to be able to see the process, it seems to me. And that's about data, isn't it?
Yeah, absolutely. Steam isn't a fixed cost, it's a controllable cost. And but you need the data to be able to monitor and optimize it. I'm just looking at the steam water cycle just for a simple system, and I've just got a boiler house with 3 boilers in here, a steam header, and the steam going out to 2 processes in the production area, process A and B. The heat supplied to these processes could be a reason of different applications here, some mentioned here. Indeed. And then the condensates push back under its own vapor pressure to a condensate recovery vessel and then pump back into the hot well or deaerator. So a simple cycle. These boilers have economisers, so the flue gases are preheating the feed water, which will improve the efficiency by a couple of percent. We're looking at temperatures across that economiser. Now these need to be a matched pair of temperature sensors. It's no use just taking 2 different temperature sensors and popping them here. These need to be a match pair, and the reason there is that we might only be adding 10 or 20 degrees of heat into that feed water, and if there's a couple of degrees just taken in the difference to here, that's a significant percentage. Indeed. So we try and nullify that by having a matched pair. And next to each of these meters is a little box, a little flow computer. So this is calculating the mass and the heat. And most of these meters, such as a steam meter here, is measuring the volume. So there's a pressure transmitter or a temperature, and then a flow computer. So this is how we measure the mass and the heat. So these flow computers are also on the condensate. So we're measuring the amount of heat returned, measuring the amount of heat and the mass of the feed water, and the mass and the heat of the steam. The fuel needs to be in the right units as well, absolutely critical, because if we're going to get kilowatt hours from this, then we need to get this fuel measurement in the right units. So again, volume isn't very helpful to us. Just a note on some of the meters today, fairly modern meters, they'll provide multivariables. So you can get mag meters now that'll have a conductivity measurement in there. That'll give you an idea of what's happening to maybe the water quality in the RO plant, just as an additional variable.
That's something. Is that something new? It's a case of, let's look at not just the data, but let's look at that on certainly a more granular level. Let's really dive into that. And the great news is we can monitor that, and we do have the meters now. We do have the pumping capability to be able to do that. So the data is available as long as you put that together into an integrated system.
Exactly, and this is why sensors are becoming more and more capable of providing us multivariables. This is a great example, the steam meter. We can get mass, we can get heat, we can get the dryness fraction of the steam, so we can get the quality and how much moisture is in that steam. So traditionally, if we looked at analog outputs, then we have to put all our eggs in one basket with those signals. And if we take digital communications from these measurements, then we can get all of those multivariables on the same wire, and that's what we tend to do. We will use digital communications from all of these boxes and pull out more than one variable, and in some cases up to about 10 variables, and they're all useful for different reasons. Some for diagnostics, some for different types of KPIs.
And what do you find from your customer base? Are they near to this ideal, or do you find that there's still some work to be done to achieve this level of monitoring and this level of sort of data gathering?
I think if you buy a modern boiler today, it'll be very well instrumented. There's a cost associated with it, but people realise that the main cost is in the fuel over the lifetime, and not some additional instruments. When you do go around boiler houses, though, you do see a few gaps. So perhaps you won't see the match pair of temperatures on the feed water. Perhaps you won't see the feed water meter itself. Mainly, you see the fuel meter and the steam meter, and quite often these are not measuring the right units.
Sure.
But at least they're there, and they can give you some sort of measure of the fuel economy.
It's a level of information, but I think. Well, I guess what Endress+Hauser is ultimately saying is, if you are in this situation, you are looking at your boiler house. There's quite a lot you could do. Clearly, you have a baseline which you've been using potentially for years, but you couldn't essentially take a quantum leap and start looking at your inputs in a much more detail, and ultimately. That's hopefully going to make your process more efficient. That's going to save you some money because you can see what's happening within your boiler house. You can do that today, but I guess the ultimate is that you can do a lot more with that, and we do have the measuring tools to be able to do that.
Yeah, absolutely. We've had customers who've been looking at putting magnets on fuel lines in the past, and they haven't sufficiently instrumented the boilers, so they would never know if these magnets were actually going to do anything. And after instrumenting the boiler, for sure there was no change.
It's integration, isn't it, Wes? It's all about take a step back, understand what you want to do, and you can do all of those things, but they have to be done with some kind of strategic plan. You can't just throw a meter onto a certain area and hope that you're going to pull some information off and deliver some KPIs. That's kind of not going to work, is it? You must think of these systems as an integrated whole.
Yeah, absolutely. And the one thing I always focus on is the units of measurement. Everything is about the units of measurement. There's lots of ways of measuring the variable, but you've got to get the right units.
Indeed.
I've just shown in the next slide. We've got a data manager. There's lots of these on the market, and they're quite powerful. And this is very cost effective because it's done all of the calculations that we were doing with individual flow computers here. It's done them all in one box, and it's also been able to do some of these KPIs that we just talked about. So by looking at the mass in and the mass out, we can look at the blowdown. By looking at the heat in and the heat out and the fuel in, we can look at the fuel steam efficiency. By looking at the condensate return, we can look at how much of the steam we're getting back as water, so percent condensate return. So there's lots of KPIs we can do, and these can be performed in a box like these. They can be done in a BMS or a PLC or SCADA, but if they're done here, they're done dynamically, within seconds of the measurements being made.
And is that meter something that can be attached to an existing system fairly easily? We're not talking huge amounts of work to put that in place.
No, these data managers can take legacy equipment, so anything that's already measured. If there was a mechanical turbine meter on the gas, then that just needs pressure and temperature. We could pull those in and do a corrected volume calculation here, so now we've got the right units. We can get the energy measurements. Similarly here, if we haven't got the heat, we can do the heat calculation in here as well.
That's a powerful piece of kit. If you haven't got that, that's kind of essential.
That's right. It fills all the gaps really. Indeed. And helps you get all the units correct.
Indeed. Yeah.
And I just mentioned about having the right units. The other thing on the steam line is that the meter's installed properly. So here we've got a meter, and most steam meters are velocity sensitive. So, which usually means that we reduce the line in order to get better turn down from that technology. And in just reducing the line using concentric reducers here, then we'd create a dam for this condensate if it was to build up. And this is the last thing we want to do, because this will cause water hammer, it'll affect the measurement, it'll actually do damage to the line. So instead we use a concentric reducer like this one. And you can see the concentric reducer here. There's whatever straight lengths it needs, from 6 to 10 to 15, depending on the type of technology. Then the meter, then back out again. So we've even rotated the meter 90 degrees here as well. So you can see now there's nothing stopping the flow of condensate through this meter. So rotating the meter using concentric reducers is something we do all the time with steam measurement, just to ensure that that condensate can freely pass the meter and drain.
And it seems to be that's an easy gain. That's an easy win inside inside your boiler house. Something as simple as that. Suddenly, you're looking at really improving how you're managing a component of that. In this case, the condensate. Because it can easily be sort of overlooked, but it isn't, because that's a valuable resource for inputting back into the system, isn't it?
It is, and if you've got this type of installation using concentric reducers, then some of this water then can impinge on the sensors, and it can affect the turn down, affect the measurement accuracy, and cause you massive problems in the steam system. The other thing I mentioned, which is we see very often, is trying to get the right units out of the gas or the fuel meter. So we use different technologies, but this is taken from the National Grid website, and it just shows you what the composition of the natural gas is. It shows you what the from 119 samples, what the maximum percent of the various components in natural gas. It's a composite with propane, carbon dioxide, ethane, nitrogen, methane. And so it's important to know this. It's important depending on the technology you're using. And we set up our thermal mass meters with a gas engine in with this composition, which is an average of these, which works really well. Now, the key thing about the measurement of gas is that it should be corrected. The volumes that we're getting need to be corrected to standard conditions. So this is a caption again from the National Grid website, and it's just to highlight that the CV of gas is actually it's the amount of megajoules, the amount of energy you've got in a cubic meter, but that cubic meter's reference to standard conditions. So standard conditions are 15 degrees C and 1.013 bar absolute. And if we're going to get fuel and we're going to try and convert it to kilowatt hours, we have to have the right units. You can't just have volume that's corrected to 0 degrees and multiply it by the calorific value that's corrected to 15 degrees. You'll get a 5% error in the energy. So attention to detail has to be made to get the units that are corrected to 15 degrees C. And we see this a lot with people trying to look at efficiency calculations of boilers, and they've got gas meters that are not corrected to 15 degrees C properly. And there'll be a 5% error there. And again, it's the gross CV that you're using. And typically in the National Grid, we're looking at something between 37 and 43 megajoule per cubic meter, and that averages to just under 40 megajoule per cubic meter.
Well, is it? I mean, the standard condition, as you explained it, it's there from the National Grid. But on a sort of, I guess, process by process or a boiler room by boiler room basis, is that often overlooked? Do you often see that when you're going in? Someone said, "We're getting this data, we don't understand it, and it's wrong. What's going on?" And it's because it has not been, I guess, adjusted for standard conditions, and that's where the data needs to I guess, the data that put in is accurate when it comes out, but it has to be at a standard. There has to be a baseline, and that baseline is the standard conditions, isn't it?
Yeah, absolutely. We see it a lot. I think it's the UK. Our whole grid is reference to 15 degrees. It's not the same in other European countries.
Yeah.
And so if you've got European manufacturers, you've got gas meters, they might just have a default setting of normal cubic meters, and normalized is 0 degrees. And again, you've got the wrong reference date conditions. You'll get the wrong energy that's calculated. It'll be out by 5%.
5%'s a lot, isn't it, Wes?
Yeah, it is.
That's a big number.
Yeah, it is. So we're just coming on to these KPIs now, and we're just looking at how these are calculated. So a little bit of schoolboy physics.
Oh, go on then. Yep, let's do that.
It's nothing too complicated, but if we measure things correctly, the calculation becomes even more simple for us. And
Sure.
And what we're trying to do with efficiency is just look at the energy in and out. So it's just the energy out, which is the net energy. So this is we're taking away the energy we're putting in through the feed water, which is preheated. So we're looking at the net energy out, and we're looking at the energy in through the fuel. So very simple method of calculating the performance. There's all sorts of efficiencies with associated with boilers, but it's the fuel to steam efficiency that's the most useful. This has the direct bearing to the costs.
Absolutely.
And if we look at kilowatt hours, for example, as an energy unit, and we just try and get everything in those units, then the calculation becomes really simple. So if we look at the kilowatt hours in the steam, again, we've got to convert volume to mass and mass to heat. But if we get the heat in the steam and we take away the heat that we're adding in the feed water, again, most people don't have meters on the feed water. So if you did, you can really account for what's happening with the blowdown and with the preheating of the feed water. But we can obtain the net heat then really simply by just taking away that feed water heat, and then we divide that by the energy in the fuel. And again, that's paying attention to the units, the corrected volume units, corrected to 15 degrees C. And if we do that, it's a very simple calculation. This next one is what a lot of people do when they ignore the flow meter here. So what they're doing is assuming really that there's no blowdown, and they're assuming what goes in comes out, just to get an easy way of calculating the efficiency, but without using as many instruments. You'll be a couple of percent out in the calculation, but this way we're looking at the steam mass, and the mass they're assuming is the same mass throughout the system. They're looking at the difference in the specific enthalpy. So this is the heat content of the steam at wherever pressure this is from steam tables, and the feed water specific enthalpy at this temperature here, wherever it is in steam tables again. And again, we're just dividing that by the corrected volume times the calorific value. It's a couple of percent out because you're not taking into account what's happened with blowdown. And blowdown itself is obviously just what's going in less what's coming out. The difference we're associating with what's been blown down. And it's not unusual to see blowdown values of excess 10%. And ideally, we should try and get within 10%. This is just wasted energy. So to track this is a good indicator of anything happening. The percent blowdown, obviously, from that is it's just what the blowdown is divided by that feed water as a percentage. And the condensate return that we talked about is just the condensate mass here divided by the steam mass. So it's the percentage of that steam that we're trying to get back through condensate. And again, the more we get back, the less makeup water we'll need, so the less fuel we'll need to raise the steam. And the more heat we can recover through the economiser, the higher the temperature, the less fuel we'll need to raise steam again. So all of these parameters together give us a little indication of why the fuel to steam efficiency might be just slightly lower.
Well, that's right. That's right. I mean, for you, if you just look at that, that graphic, for you, that's kind of the ideal. That's kind of what you'd like when you walk into a boiler room. That's what you'd like to see. All of the correct parameters are there because it has all the correct sensors on it, and more importantly, they've been accurately calibrated. Everyone understands what's in, what's out. We're using the same data. And then what you get out at the end is an accurate understanding of your fuel efficiency. Ultimately, that's what we're about. But for you, that would be the ideal. If everyone's kind of had that, they could see some quite impressive improvements in their efficiency, couldn't they?
Yeah, you can certainly understand why things are perhaps lower than you'd expect, or see problems. If there could be something failed and there's too much blowdown. You would see that. You would maybe through conductivity pick up maybe a problem with a RO plant or something. So there's lots of pointers to conditions that you could use for diagnostic metering. But if there's a boiler house and there's two boilers and one boiler is usually only ever used, then you could just use the same measurements for the boiler house rather for the individual boiler. Sure. So there are ways of keeping the cost down a little bit. And there was one other parameter that we didn't touch on then, and it's looking at the cost of fuel in the process. So with obviously increasing gas prices, the profitability of products in some areas because of steam heat now costing much more can be calculated quite accurately. If you know the fuel economy, if you instrument the boiler and we get to the measurements we've just looked at, then as long as we're measuring steam in that process, then it's very simple calculation. So it's the total fuel divided by the total steam and multiplied by just the steam in that process. Now, it makes no sense when you're just looking at one process and a boiler, because obviously this steam is the same as that steam. But imagine, like before, we had two processes. Then if you measure the steam separately, then and it's all about the units, because the kilograms here cancel with this kilogram, so you're left with a calculation for that fuel, and it's in kilowatt hours. So the number you get is actually the kilowatt hours of fuel in that process, and you know what the cost of the fuel is, so you can work out the cost of heating that. And it's a variable cost. It'll change by batch, it'll change by the loading on the boiler, by any fouling or build up in the heat exchangers for the economisers. All these things affect that measurement.
But interestingly, over time, of course, that will give you all the legacy data to see efficiency. You can spot when you're using your process, when the boiler is kicking in, when you need that steam process, and so on. Over time, that information becomes, well, it's gold dust, isn't it, for improving your process over time. Particularly with inputs, because as we said, energy is expensive, and it shows no sign of slowing down and reducing. So what can you do? Well, you basically take what you have to pay for and just use that more efficiently. And if you can do that with sensing technology, if you can do that with understanding your process, and ultimately how that can be, I guess, related back to ultimate cost, the good old kilowatt hour. Which is a very easy thing to see and track on your bottom line. That seems to me to be a very powerful thing you can do on a practical level. You're not powerless, are you? You can do something about your process and hopefully improve and the efficiency, and just make the inputs work better for you, work harder for you.
That's right. And I think once you've instrumented a process, a boiler house in this way, then you need to have a way of managing the data then, and automating the reports. And that brings us to the next section, actually. But just before I do that, I just wanted to show you some of the data that's from a data management system, and it's for some of the KPIs that we've been looking at. So it's the fuel to steam efficiency here, it's the blowdown, percent blowdown here, and in a data management platform, you can represent that. It's if you've got all the data, it's easy to get the numbers correct, and you can represent it. So daily, you can look at the daily fuel to steam efficiency as we've got here. You won't get, if you instrument a boiler correctly, and even if you're using an economiser on a steam boiler, you won't get more than 84% for the fuel to steam efficiency, just because the losses in the system. So if you're suddenly doing the calculations and you're finding you've got 90%, then there's usually a problem somewhere in the units or the measurement.
It looks too good. Yeah.
And conversely, if you're down at 40% as well, there's something wrong.
There's something's gone wrong there. Yeah.
But it's
Although the blowdown percentages, those are amazing. The impact they could potentially have if you're not tracking that could be huge, couldn't it? You really need to pay attention to blowdown.
Yeah, I mean, if you're putting, if you're spending a few £1 million a year on fuel, and that's going into your boilers, and you don't understand how the boilers are kicking in, and what the load profile is on the site, you won't know what each fuel to steam efficiency is, and
ultimately it all tracks back to good old kilowatt hours, what you're paying for.
It is. And similarly, this is the percent blowdown. Again, you can set this up in software platforms again to look at this daily, and you can set alarms on this. So you can aim for under 10%. It's quite hard to achieve on some systems, but you can track that. So it takes us just to look at really some of the tools in these platforms. And just to put things in perspective, you instrument a boiler house in the way that we've looked at, the cost of a data management and reporting platform is like the cost of a heat meter. So one of those condensate heat meters, that's the sort of cost you're looking at for a platform like this. So it's almost a no-brainer, if you haven't got a way of registering all of this data and setting meaningful targets, then it's well worth looking at. There's lots of different platforms on the market, and I think they're all roughly similar sort of prices. And we talked about digital data before. Obviously, we've got to collect the data. There's the best way of doing it, the most efficient, the most accurate, is to look at digital protocols, not to look at the pulses or the analog signals from these meters, but to purely look at the digital information. Almost all of those flow meters I showed you, in fact all of them, they have a digital protocol as standard anyway. It's called HART. It's been around for decades, and some sites will only take HART. They won't take anything else. Okay. And they'll some sites will only look at Ethernet IP or Profinet or some other digital protocols. But one useful way of taking all of the energy data from these flow computers or from individual meters is to use something like Modbus over Ethernet. Very widespread, very effective protocol. Most flow computers from different manufacturers have that option as well. So now you've got all the digital information being collected into a gateway, and that gateway can sit inside the firewall and just push the data out to the cloud-based platform. So that's all we're showing really, is that all of the instrumentation we're looking at, they're all digital anyway, and we're just recommending that digital information's used when you're pulling the data together.
Is that often not the case? Is that often there'll be a misunderstanding that we have these analog devices, or we have some devices, and we just don't think it has I guess the connectivity. It's not generating the the digital information a management system could need for an input, but actually it does. And if you look at the underlying technologies like HART, all you really need is something that can take those inputs, and TCP is an example of that. And it seems to me there's a lot out there which any business, anyone listening to this webinar, you do have the inputs. All you need to think about is how you are, I guess, is really taking that information. And then using that for overseeing your process, for looking for efficiency gains. You do have the data. It's just what you do with it.
Yeah, it's what we were saying before about these steam meters. There might be 10 very useful multivariables in there, and yet people will still take a pulsed output from there. Yeah. So you take a pulsed output for either a kilogram or a kilowatt hour, when you could have about 10 multivariables. But the only way to get all of the multivariables is through the digital protocol, something like HART, or something like Modbus TCP, or Profinet, Ethernet IP, all these different protocols. They just and also, when you're collecting data from devices, you're not only taking all of the process variables, you're bringing in the health and the condition of the device. So you're bringing in diagnostic information. So
yes, because that's often overlooked, isn't it? Because I guess almost the focus of this webinar is looking at efficiency, but you have much more data there, and looking at things like let's look at how the process is performing. Let's look for any kind of issues with that. That's all available as I guess an added extra. I guess what we're saying is don't think that your data management system is just one thing. It just it looks at input. It's not. It can offer you much more granular information, which can feed back into many other areas of your business because you have the information.
Yeah, it's about going digital, isn't it? It's about the Internet of Things again. It's about having the infrastructure on site to look at all the digital multivariables, including diagnostics, and using different platforms for different things. So here we're focusing on how we could set meaningful targets for the steam and the fuel, but we could be looking at the diagnostic information and sending that to another platform and looking at an asset management application. So I just wanted to look at very briefly the typical energy monitoring software platform. So here we've got steam and fuel. This is for decades what people have been looking at on the boilers, looking at the steel and steam and the fuel, maybe in a SCADA, but the same data can be correlated slightly differently. So you can use exactly that same data and just graph it up differently. So here's the same data that we've just seen, and instead these bars now are the fuel economy of the boiler, because they're the kilowatt hours of fuel per kilogram generated of steam. So each one of these bars tells me what the fuel economy is. And again, this is a very useful benchmark, because I can see straight away if anything creeps much above 0.8, say, then I know there could be a problem. This is the blue line is just the steam loaded on the boiler. So you'd expect whenever you've got the highest loading on that boiler, you'd probably have one of the better ratios of fuel economy. This other graph here is I'm just graphing the steam consumption here on this axis against the fuel on this axis, and now they form a straight line, and the line of best fit here is just the average efficiency of that boiler. It's not to say it's good or bad. This is the average of the current operation, and you can see sometimes we've been above this line and sometimes we've been below. So for a given steam demand, say 3 tons here, sometimes we've had more fuel to raise that steam than other times. So we can set a target for the fuel on a particular boiler using this method. So this is just a simple regression analysis. So most software packages allow us to do this with data, and this is how you can start targeting fuel used to generate steam. And these are the typical tools you'll get in a software platform. So we've talked about setting the target line, and once we've got that target, this is how the data can look then. So now the origin here, this line, the 0 line, this is the target. So now we're plus and minus above this target. So this is when everything's fine. We're just above and below this line of best fit. This is how it's looking. And then if we implement something that's going to save energy, maybe reburner, we add an economiser or oxygen trim, advanced combustion control, wherever we're doing, we might want to see a change then in the efficiency. So now we would be just very consistently below that line, and that's what will happening here. So we've improved the energy efficiency. We're consistently operating below this line of best fit, and we can set alarms around an optimum band that we think is acceptable for that variation. So here we've got another analysis tool called a Q-sum. So this is the cumulative sum of these deviations here. So if we look at all the deviations and we sum these, we'll end up with a straight line here. So this is a great condition monitor, because as soon as something's changing, whether it's heat exchanger fouling up or something changing, and it's changing very slowly, and it's going to be very hard to pick up through gas bills and things like that. But we'll pick it up with a Q-sum, because instead of it being nice and flat where we're operating within limits, things start to change slightly, and then we see a deviation from that straight line. So this tells us, as a condition monitor, that something's changed. It happens to be the same data here. So this happens to be an economiser added to a boiler, and we can see a small step change in the efficiency. And this is adding up those incremental savings. It adds them all up, so we can see after a certain period of time what the saving is. This is a good way of predicting and projecting savings using these type of tools. And then we've already had a look at this one. This is the performance, the benchmark, the fuel economy, these bars. So these are all available with standard platforms, really, lots of them, very powerful, and enable us to set meaningful targets for targeting fuel into steam systems.
Yes, I think that's massively useful, because you're looking at the information you've got. But for me, I think it's looking at forward planning as well. You do something, you change something, you must be able to monitor what that's doing to the overall system. That's really that's the important thing to bear in mind, isn't it?
Yeah. Just last slide now, just to finish off. I should really add that we should see the government incentivising energy monitoring systems more in the future, and I think the reason there is we're going to see more from ISO 50001, so the energy management system, and this will be, it's already a route to compliance for ESOS assessments, but we'll probably see it as a route, or if you want to continue with a climate change agreement in the future, you'll probably need ISO 50001 as well. It's looking highly likely. So CCAs, climate change agreements, are finishing at the end of this year, but they will carry on in some other form, and an ISO 50001 is looking like a likely requirement for those to continue, and to underpin all of the data in an ISO 50001 system. something like this energy monitoring platform is going to be a requirement, a data management system to underpin all the data and to set meaningful targets. All of what we've been looking at are measurements of heat. Heat in lots of government incentives and regulations has to comply with guidelines for the type of measurement, the accuracy and security of that measurement. So I've just mentioned some here. So we've got CHPQA, RHI. So this renewable heat incentive finished last year, but the green gas supply scheme is already been launched, and that will replace RHI for biomethane injection into the grid. So the intention over the next 4 years is to decarbonise this the national grid as much as we can before hydrogen comes available later. And again, there's we mentioned that heat networks are going to double by the end of the decade. There are compliance again for heat meters in those networks, heat network regulations. For large sites, we've got the UK emissions trading scheme. Again, all sorts of different compliance requirements, and lots of different measurements come under this. And there is an obligation for customers with compliant metering that they have to keep them within the specification. So calibration is important, and lots of meters nowadays have electronic fingerprinting, if you like. So you can use tooling to verify the meter without taking it out of the pipe. So this is something that Ofgem have accepted as an applicable method of as an alternative to calibration, something that if done regularly can push back that wet calibration requirement. And obviously it's not invasive, you don't have to take the meters out and put them on a rig. So that's me finished. Any questions?
Well, nothing's coming from our attendees. At least nothing that I've seen at the moment. But I had a question which I was sort of saving for the end, I guess, and here we are. I think for everyone sort of attending today, if you could give them one piece of advice, once you've finished listening to us, what should they do? Is there some practical thing? Go away and do this today to get you on the road to more efficiency, in your boiler room. Is there something that time and time again it's the first thing that you always advise when you're out talking to your client base?
Yeah, you need to be able to determine the fuel economy of the boiler. You wouldn't buy a car, would you, that didn't tell you the miles per gallon, and you've got some way of seeing what your fuel economy is on your car. So the same with the boiler, and again, the second thing is the attention to units, because without getting the fuel economy in the correct units, it's not really accurate.
That's fantastic. Well, if there's no further questions, I'd like to basically thank you all for attending this webinar, Analyse and Optimise Decarbonising Energy through Efficiency in Boiler House from Endress+Hauser, presented to you by Process Industry Informer magazine. I'd also like to thank Wes for the presentation. I thought that was really insightful. I think there's lots that people will take away from today, lots to think about, and I guess more importantly, a detailed look at process and energy and how all these systems really need to integrate together. And ultimately, if you can gather the data from your system or from your boiler house, you're in a massively more secure position when it comes to energy efficiency. What you guys are paying for your energy. So I'd like to thank Wes. Thanks again for coming on today. So it's goodbye from me, Dave Hull, and it's goodbye from Wes.